Hi, in this video we're going to write linear inequalities from word problems. Before we do so, if you have not subscribed so already, go ahead and do so right now so you'll have access to more of these kinds of videos. And if at any point you find this topic useful or insightful, go ahead and click the like button. That lets me know that some part of this was helpful. Alright, let's begin. Before we begin, I definitely want to show or review a little bit of some keywords we're going to be using to be able to express the inequality. For example, we have 5 scenarios here. And this first one we have, Sue has a maximum of $120 in her account. Maximum is another way of saying less than or equal to. Because $120 is the most that she'll have in her account. So we start with 120, and anything less than that will be true in her account. This next one, Chen's account balance is above $50. So the account balance is more than $50. So we use the symbol greater than. Angelica has no more than $230 in her account. So no more than that means she cannot have 231, 232, 233. It's got to be less than or equal to 230. Kadeem has at least $72. The key word here is at least, which means it's got to be more than $72. So at least represents the 72 or more. So we say greater than or equal to. And lastly, Bo's account has no less than $15. No less than $15 is another way of saying you cannot have 14, you cannot have 13, 12, or 10. You can have no less than 15, so it's at least $15, or greater than or equal to $15. You could have 15 or more. So our goal through this next video is to talk about different scenarios where we analyze the word problem and we try to write an inequality from it. And our goal is to first find these keywords along the way and to write a representation, whether using the less than symbol, using the less than or equal to symbol, using the greater than symbol, or the greater than or equal to symbol. We're going to highlight the keywords that we're going to be using, write the inequality, and then go from there to solve some problems. In this first scenario, we have Jamie wanting to buy a combination of strawberries and blackberries. Notice how here the strawberries are worth $2.50 per pound and the blackberries are $4 per pound. Jamie wants to spend a maximum of $20 on berries. So you can buy strawberries and blackberries, and a combination of that, you can only spend a maximum of $20. So maybe mom gave Jamie $20 bill. It's like, hey, this is your limit. That's right. Which means that the key word here is a maximum of $20. If my spending limit is $20, then I have to spend less than or equal to the $20 that I'm allowed. I can't spend 21. I can't even spend $20.10. I don't have that amount. So, how do we write an inequality? Whenever you see the word possible combinations, combinations means you're going to add strawberries and blackberries to get at most $20. So, I start with $2.50 per strawberry plus $4 per blackberries, and I can only spend a maximum of $20. And I've already used this symbol to represent that. So instead of pressing the equal symbol, I'm going to use the symbol that I use for my inequality. And that's it. That's how you would write your inequality. Now we're going to use this inequality to answer questions about the problem. Jamie has 2 pounds of strawberries in her basket. Write an inequality to represent the possible pounds of blackberries she can purchase. So, Jamie already is planning on buying 2 pounds of strawberries. How many pounds of blackberries can she purchase with however much money she has left over? So I'm going to use my previous problem, or the previous scenario right here, And I already know you're spending $2 pounds of strawberries. So I'm going to substitute the 2 pounds in here. So $2.50 times 2, and that is a total of $5. She's already planning on spending $5 on strawberries. How much can she spend on blackberries if she still has the $20 limit? So then I write the rest of the inequality. Plus 4y has to be less than or equal to 20. Right? Then I solve for y, because I want to figure out how many pounds of blackberries she can purchase. So I subtract 5 on both sides. I have $4 per blackberry. It's going to be less than $15. That's supposed to be a 5, by the way. And then if I divide both sides by 4, let's see. I'm going to put this in here. If I divide both sides by 4, I know that I have y is less than or equal to 15 divided by 4 is 3 pounds, 3.75 pounds. So what does this mean? It means that if she already plans on spending or buying 2 pounds of strawberries, she has to buy less than 3.75 pounds of blackberries to still stay within her budget, her $20 budget. Let's try another example. Leon has a jar full of dimes and quarters. So here we're talking about money, dimes and quarters. The total value of the coins is at least $30. There's my keyword, at least. At least means more than or equal to $30. So greater than or equal to $30 is what I'm trying to keep in my budget. I gotta have more than that. Sorry, there's no budget here. It's at least $30 that we're looking at doing. So we want to write an inequality representing the combinations of x, the quarters in the jar, and y, the number of dimes in the jar. So we got quarters and we have dimes. Quarters are going to be represented as 0.25 of a dollar, so we can put 0.25x, plus dimes are going to be represented as 0.10 y, and we say that the jar will have at least $30, so greater than or equal to 30. It's important that I write decimals for the quarters and decimals for the dimes because $30 has to be more than one whole of a dollar. Okay? So, this is going to be the inequality that we're going to be using to represent our scenario. 0.25x plus 0.10y will be greater than or equal to 30. Now we want to answer some questions from it. Is it possible for Leon to have 100 quarters and 50 dimes? 100 quarters and 50 dimes. Is it possible for this to happen in this scenario? All we got to do is substitute the 100 quarters. Let me change colors. The 100 quarters into x and the 50 dimes into y and find out, is that still at least $30? If I add these two together, will I still have that amount? So what we will do is we'll plug them in, and this is what it'll look like. A 100 times 0.25 is going to be the same as $25. 50 times 10, the dimes, which is 10 cents each, 50 times 0.10 is $5. Is this still greater than or equal to $30? And the answer is yes. 25 plus 5 is 30. And 30 is definitely greater than or equal to 30. It's actually equal to 30. But anything greater than 30, we would have accepted. So yes, we can have 100 quarters and 50 dimes. We could have 110 quarters and 50 dimes. Because anything more than that will be at least $30. Alright, this last scenario. If Leon has a total of 90 quarters in the jar, write an inequality to represent y, the possible number of dimes that are in the jar. So we know that there's 90 quarters in the jar. That value represents x. So I'm going to plug in the 90 into x. I have 0.25 times the 90 quarters plus 0.10y has to be greater than or equal to $30. I want to solve for y to show how many possible dimes I can have in the jar. 0.25 times 90 is $22.50. So 22.50 plus 0.10y. To solve for y, I gotta get rid of the 2250. So I subtract 2250 on both sides. .10y is greater than or equal to 30 minus 2250. That's $7.50. I'm just gonna put this up here already. The next step is to divide both sides by 10. Or before I put it in there, let me just continue solving down here. Divide both by 0.10. Y has to be greater than or equal to 7.50 divided by 0.10. That's 75. What does this mean? It means that he has to have at least 75 dimes in the jar for him to have at least $30. And that's how we find it. We plug in what we know into the variable that we know, and we solve for the missing variable. And that'll tell us how many number of dimes, or whatever it is that we're looking for, has to happen for this original inequality to be satisfied. Okay. In this next scenario, we have a local restaurant has a drive-through and dine-in option. In the last hour, the restaurant served no more than 70 customers. No more than is another way of expressing what inequality. No more than. So you can't have 71, you can't have 72 customers. 70 is the limit of how much they have served, which means we're dealing with less than or equal to. No more than $70. 70 customers. Write an inequality to represent the possible combinations of x and y, and then create a graph. So we're going to add the number of dine-in customers plus the number of drive-through customers, and we want to have less than or equal to 70. To graph this inequality, I want to make sure that I have it in the y format, ymx plus b. So I want to get rid of the x. I subtract x on both sides, and I have y is less than or equal to negative x plus 70. Now, how do I graph that inequality here? Remember, we're looking at mx plus b. We start with the y-intercept, and the slope here is negative 1. Negative 1 over 1. So I start at 70. And then the slope is negative 1 over 1. And since these sides go by tens, 10 divided by 10 is also 1. 20 divided by 20 is also 1. So the rise over run will be the equivalent of going down 10 and over 10. Right? This is what I'm saying. 10 over 10 is the same thing as having the slope of 1 over 1. And since we're going down, we're going to go down to the negatives. Down 10 over 10. So I can just connect the points here. Down 10 over 10. Down 10 over 10. And I'm trying to keep this line straight. Okay, so I'm going to connect these dots with a line. Will it be a solid line or a dotted line? Well, if we recall from our last video, the equal to symbol makes it a solid line. Now there it is. Here we have a scenario where you can have a certain amount of customers and a certain amount of dine-in customers and drive-through customers to give you no more than the 70 in that hour. Okay? Now, since we're dealing with the less than or equal to, are we shading above or below? Yes, below. Less than means below than. So we're going to shade everything below that. This line will be part of our solution. Anything in that shaded region can be a combination that the restaurant had in the last hour. Right? And if you think about it, you could have 20 dine-in and you could have 30 drive-through. 20 plus 30 is 50, which is still less than 70 customers. Explain how you can use the graph to determine the number of drive-through customers there were if the restaurant served 20 dine-in customers. And that's really what I was talking about. Right? Anything in that shaded region, we should be good. Now, X represents the dine-in customers. So this axis here on the bottom is dine-in customers. I'm going to write that real quick so I can remember. X is dine-in. And Y represents drive-through. That's just this one that says drive-through. So if I know I have 20 dine-in customers, here's my scenario. I have 20 dine-in customers down here. Then what are the possible drive-through customer scenarios? Anything in this section up to this number, the 50. Everything in here. So if I have 20, I could have 10 drive-throughs. 20 plus 10 is 30. That's still less than 70. I could have 20 drive-throughs. 20 plus 20 is 40. 20 plus 30. 20 plus 40. And 20 plus 50. All those possible scenarios would mean I would still have less than 70 customers if I knew that I served 20 dine-in customers in total. So that's how you would use a graph. Anything in the shaded region is going to be a possibility under 20. All right, for our last scenario, last example here. Lila's workout consisted of a combination of swimming and running. Lila burns an average of 8 calories per minute swimming and 20 calories per minute running. So I'm going to be dealing with swimming plus running, right? That's my scenario here. If Layla burned less than 360 calories in her workout, less than being my key word that I will go back to in a minute, write an inequality that represents the possible combinations of minutes she spent swimming and y that she spent running. Then create a graph in the situation. So, let's highlight my keywords here. The keyword here is that she burned less than, that was supposed to be less than 360 calories in her workout. Less than is a symbol representation of literally less than. So we're looking at something that's less than 360. Okay? Now, I know from the beginning that an average of 8 calories per minute for swimming and 12 calories per running. So if X represents swimming and Y represents running, my inequality goes like this. 8 per swimming. Per means multiplication. So we're dealing with 8x plus 12y has to be less than 360 calories. That's my inequality. 8x plus 12y is less than 360. So, to be able to graph this, I need to convert this to y equal notation. I want to make sure that it's a y equals mx plus b form, or y is less than mx plus b. So I'm going to move the x to the other side. Let's move this back down for a second. I'm going to move the x to the other side, leave y by itself, and then graph it. So I subtract 8x on both sides. I'm left with 12y is less than the negative 8x and plus 360 because it's a positive 360. To leave y by itself, I divide everything by 12. Let me move this up a little bit. I have y is less than negative 8 over 12. They're both divisible by 4. 8 divided by 4 is 2. And 12 divided by 4 is 3. And then 360 divided by 12 should be 30. So I get plus 30. So now my goal is to graph this and to figure out what the shader region looks like. Let's move this in parts. Put it here on the left. I'll put this in the right. That's the part that we really worry about. We want to know how to graph it. So what does this mean? I have mx plus b. The things that I want to ask myself is what kind of line am I doing? Solid or dotted? And where am I shading, above or below? The less than, there's no equal symbol, which means we're going to have a dotted line. Okay, I'm going to make a note of that to myself here on the side. I'm dealing with a dotted line. And because it's less than, I'm shading below. So let's graph this equation. We start at 30. The slope is negative 2 over 3. Now, we are going in increments of 5. So this is going to be a very rough sketch of what we're expecting. We're going to go down 2 over 3. Down 2 over 3, down 2 over 3. And if you follow these little dots along the way, we should have, give me a second. It should stop over here at 45. Now, because the slope doesn't align with that, what I did here was this. I know my y-intercept, right? I can look at my original situation. Let's do a quick recap. 8x plus 12y less than 360. Here's another way of graphing in standard form. What we do is we want to find the y-intercept, so we're going to plug 0 for x. If I cover this with 0, and I divide both sides by 12, I'm going to do this in two colors. I'm going to assume that this doesn't exist. I'm finding the y-intercept, so I divide both sides by 12. Y then equals 30. That's how I find my y-intercept. Then I repeat this process to find the x-intercept. So I cover the y, and I solve for x. Divide both sides by 8. And then x equals 45. So we have our x-intercept, y-intercept, and then we're just going to connect these 2 points because the slope's going to be kind of off with dotted lines. And because we're doing less than, we're shading everything below this. Should be part of our solution set. So, is it possible that Layla swam for 30 minutes and ran for 10 minutes? Now, the x-axis represents swimming. So, if we go to 30 for swimming, is it possible she goes 30 swimming and ran for 10 minutes? So I find that ordered pair. Is that a possibility? Now, because my graph is not very accurate, because it was a very, very big sketch, I can check this out by doing this by hand. Is it possible to have 30 for x and 10 for y and still be less than the original scenario? So I take the scenario, I plug in for x, 30, for y, I plug in the 10, and is it still less than 360? So what I'm doing right now is I'm going to my original inequality right there. I'm plugging in for 30 for x and 10 for y. So I have 8 times 30 plus 12 times 10. I want to know if that's still less than the calories she burned. And I simplify. 30 times 8 is 240. 12 times 10 is 120. Is this still less than 360? 240 plus 120 is 360. Is 360 less than 360? The answer is no. That combination would not work in this scenario because we're dealing with the less than symbol, not less than or equal to. Whenever the point lands right on a dotted line, we cannot count that as part of a solution. It'll only count on the line if it's part of a solid line, which then includes that as our solution. I hope this has helped. If at any point you felt that you understood some stuff and some stuff that you didn't, honestly, just go back and focus on the examples that made more sense to you. Maybe working with dollars, right? Quarters and dimes made more sense to you. Maybe working with calories. Maybe working with strawberries and blackberries. Like, pick a scenario that made sense to you and stick to that one. Use those to better understand your situation. All right. I hope this has helped you guys. Don't forget to subscribe and like us below. And as always, we'll calculate later.